So today what you guys are going to do is you're going to learn about factoring special types of polynomials. So your first target is I can factor trinomials of the form ax squared plus bx plus c. And this is a review. We've done this before. Okay? And today what we're going to talk about is I can factor the difference of two squares. So this is a special pattern such as x squared minus 16, which is called the difference of two squares. You're also going to learn a pattern for I can factor the perfect square trinomials, which would be like x squared plus 4x plus 4. So what I'd like you guys to do right now is to multiply the following in your warm-up. You're going to do number 1 through 6. And don't forget that, for example, on number 1, the 2 means repeated multiplication. So we're taking x plus 5 times x plus 5. Okay? So you're going to pause the video and FOIL out 1 through 6. And then unpause the video when you're ready to move on. Okay, so hopefully doing the warm-up of number 1 through 6 wasn't too horrible. What you guys are going to do now is, first of all, we're going to talk about what happens when you multiply conjugates together. So remember, conjugates are when you have terms that are exactly the same except for the sign, so number 4, 5, and 6. So notice what happens when we multiply the conjugates together. The middle terms cancel out. Okay, so what we're going to do today is we are going to take a trinomial, such as x squared plus 10x plus 25, and we're going to learn to factor it to x plus 5 times x plus 5. You're going to take x squared minus 6x plus 9, and again, you're going to factor it to x minus 3, okay? You're also going to learn how to take x squared minus 25 and factor it back to x plus 5, x minus 5, okay? So this leads us to these two special patterns. Now you don't have to memorize these patterns. It's just important that you understand where they come from. Personally, I love the difference of squares. I think it's very important and easy to recognize. So we can use the difference of squares when we have a perfect square and another perfect square. So for example, if I was talking about x squared minus 25, square root of x squared is x. Square root of 25 is 5. So this is going to factor to x plus 5, x minus 5. So the special pattern is saying x plus y times x minus y. So again, our example was x squared minus 25. Square root of both these, we get x and a 5. So we'd say x plus 5, x minus 5. Okay. Now the other one, well, so let's go back. Number 4 through 6 are all examples of difference of squares. Because notice we have no middle terms. They all drop out because 4, 5, and 6 are all conjugates. Now the next one is called factoring perfect square trinomials. So what this means is if you have x squared plus 2xy plus y squared, this can factor to x plus y times x plus y, or x plus y squared. So if we go back up to example 1, this is a perfect example of it, okay? What it factors to is x squared plus 10x plus 25. What I'm allowed to do is take square root of x squared, which is x, square root of 25, which is 5. We're going to write it twice, because we know this middle part right here is equivalent to 2 times x times 5. And then the perfect square trinomial, when we're talking about a difference, it would just be x minus y times x minus y, or x minus y squared. And this would be an example of number 2, 4, 3. So again, you don't have to memorize these patterns, but it's important to note that we can start recognizing them. So these three are highlighted in green are what we're going to be working on factoring today.